Great, it's recording now. Review for final exam. Question number 1 deals with figuring out if this relation is a function or not. And if it's a function, you're supposed to state the domain and the range, right? Otherwise, you should say not a function. Recall the definition of a function, right? Recall for a function, what is needed? For each input value, exactly one output value, right? To put it simple, we don't want input values to be repeated, right? We don't want input values to be repeated. That's to put it simple, output. Okay, so you check, right? The input values, -3, 0, 4, and 6. None of them is repeated. So it means that you are looking at a function, right? Sometimes students ask me, Professor, could you explain that better? When this then will be a function? Well, if you have doubts about this condition, if it's not, you're not sure about this being a function or not, you can graph it. You can graph it using sets and arrows, okay? Sets and arrows. Lucero, welcome. We just started with a review for a final exam, right? Look, input -3 goes with output -6. Input 0 goes with 4. Input 4 goes with 2. Output input 6 goes with output -2, right? So there you have the first set, second set, and you see that all the arrows are good. You don't see this bifurcation, right? This is not good for functions. However, this is okay. So in case you use sets and arrows and you see this is good for a function, but this is not good, right? Remember what we talked about when we said that at a given time, a person cannot be at 2 different places at a given time, right? That's kind of the idea of this function, right? So avoid this bifurcation and you should be okay, right? And that is just by checking that none of the input values are repeated. All right, so we figured out that this is a function. So now, welcome Cam, we just started. Now the set of all first components of this order pairs is called the domain. So this should be the domain, right? And the set of all second components is called the range. So the range will be this, right? So I hope you guys are okay with this, right? And check, this is not the only possible outcome for this, right? Sometimes it's not a function. So check throughout our worksheet, there are more examples there. So make sure that you are good with all the scenarios. Avoid always this fork, right? Great. All right, next question number 2 is asking you to figure out what is f of x plus h, knowing that the function f of x is 2x squared plus 4x minus 1, right? Remember, guys, the function are defined in such a way that these variables, in this case x, they are just placeholders, right? Placeholders. So this function is telling you is square whatever the input is, in this case x plus h, multiply by 2 plus 4 times whatever the input is x plus h, right? So when you see x, you write x plus h instead, and then just work this out algebraically. Algebraically, x plus h squared is x plus h times x plus h, right? This guy, once you distribute the multiplication, becomes 4x plus 4h. This guy minus 1, right? Just do the algebraic work. Now here, you have to FOIL this out, right? X times x squared, x times h, x. Here, h times x, h times x, and h times h squared, right? Keep it inside parentheses. Notice there is a number 2 outside waiting, right? Waiting. So do this carefully. And not hard to see that these two together, since they are the same, x times h the same as um, h times x, they will lead to the following, right? Let's write it here. They will lead to the following. Mhm, twice x squared plus twice xh, right? The sum of these two, plus h squared plus 4x plus 4h minus 1. Final distribution of 2 over this polynomial, right? So 4xh plus 2h squared plus 4x plus 4h minus 1. Check if you can combine like terms. When we check, it is not possible to combine like terms, right? So therefore, it means that this is it. This is the end. This should be your final answer, right? Final answer, right? So check for that among the choices. I know how to see that is this. Now, general advice, guys, when you're taking your final exam, make sure when you choose your final answer that you're choosing the right one. Go term by term. Look, 2x squared, 4xh, 4xh, 2h squared, 2h squared, 4x, 4x, 4h minus 1, right? One by one, because notice that the choices are very similar, very close to each other. So be careful, choose the right one, right? Take your time. You will be given 4 hours as usual. So make sure you choose well your answers. Next question deals with finding the domain of this function. We talk about this, right? We said the domain can be found by setting the denominator equal to 0. But since I'm going to set the denominator equal to 0, allow me to factor this guy, the denominator factor, right? How do you factor x squared minus 9? Noticing that 9 is 3 squared, x squared minus 3 squared factors as x minus 3 times x plus 3. And once you set denominator equal to 0, you are supposed to simplify also, right? But there's nothing to simplify there. So let's just set our denominator equal to 0. From there, you will get the values that make the denominator equal to 0, which is what you have to avoid at all costs, right? This is saying that the denominator will be 0 if you let x be either 3 or negative 3, right? So these are the values that you have to take away from the real numbers. So therefore, the domain will be the set of all x such that this bar that you see here means such that, right? Such that x is not equal to 3 and x not equal to negative 3, right? Negative 3. So these are the ones that you have to avoid, right? So therefore, this guy, right? You follow, guys? Mm-hmm. Yeah, great. So yeah, excellent, right? This is called set builder notation. We know that, right? So set the denominator equal to 0, take away these values from the real numbers. That's the domain, right? Good. Yeah, I'm gonna go kind of in order, but I may skip some of the questions. But if you feel like I should go over the questions I'm skipping, just let me know, please. This one deals with finding the range from the graph. Remember, from the graph, you can find the range, the domain. In this case, you're interested in the range. For the range, you have to figure out what is the largest output value and what is the lowest output value, right? That is why I am considering this horizontal strip. Largest an output value could be is 2, clearly, right? And lowest an output value can be is -4, right? So therefore range B, -4, the lowest value first, brackets, because it includes -4, notice the solid circle, and here 2 is also included, right? Because it's part of the graph. So bracket again. So -4 up to 2 included. So this guy, right? Yeah, very good. That's was for number 4. Great, moving on. We talk about piecewise functions, right? And I show you how to evaluate these piecewise functions, right? They want you to evaluate f, the input value 4. But for that, you have to figure out where this input value is, right? In this set, the one determined at x less than 1, or maybe here, or maybe here. Clearly, once you check for these 3 sets, the value 4 belongs to this set, the one determined by this set, right? X greater or equal than 4, or less than or equal than 6. It's there. So therefore, you have to consider this formula, right? For the evaluation. So this will be 4 times, you put this instead of x, right? 4 times 4, 16. 16. That's it, right? That's it. Very good, guys. Moving on, moving on. Then they say use the graph of f to determine the interval where the function is increasing and where the function is decreasing. For this, I gave you this hint, right? Try to travel, you know, this continues up here forever, up here forever. I said try to travel from left to right along the function and see where it's decreasing. Clearly here is decreasing, right? But also here, right? Also here decreasing. Over this little piece increasing, and over here increasing, right? We did this in class, increasing. So then just say, right, decreasing from negative infinity. Remember negative infinity is here. Up to what? Up to this guy, which is -1, right? Then increasing from -1 to 0, then from 0 to 1 decreasing, and from 1 to infinity, which is here, increasing again, right? All that is summarized here. Okay? Increasing and over this interval, this, right? Together, this union means together with the interval from 1 to infinity, right? Infinity, and decreasing over the blue part, right? Very good. I hope you're okay with this guy. Moving on. This one is similar. Let's quickly go over this. They want you to locate relative maximum and relative minimum points on the graph. Stay where each relative extremum point is a turning point. Turning points are points where the trend changes from increasing to decreasing or from decreasing to increasing, right? So quickly you notice that all these 3 points are turning points, right? They're all turning points. But besides that, again, if you travel along the graph from left to right, this will be decreasing, changes to increasing, then decreasing again. And here it changes to increasing, right? Where the trend changes, these points are called either local maximum, local minimum. This clearly is a local mean, right? Because in the neighborhood of -4 is a minimum, right? Local mean. Then here, you have a mountain, local max, right? Local max. Here, we call it valleys, right? The bottom of a valley, so local mean again, right? Now this word local can be replaced by relative, right? Relative minimum, relative maximum here, right? All right. So now also this one, since it's the lowest between these two, right? Comparing in the overall, the lowest is called also absolute mean, right? Absolute minimum. All right. No absolute maximum, because notice this continues growing forever. This continues growing forever. This function doesn't have an upper bound, right? Upper bound. So all that put together is this, guys. Look, -4, 2,4 is a relative maximum. This, right? Consistent local maximum or relative maximum. Point and turning point also, right? They're all turning points, right? These 3 are turning point. Maybe I should write here. This, that the 3 points that we selected here, right? These 3 are turning points, because the trend changes in each of these 3, right? These 3 points. This, and yeah, so then -4, -1 is a local minimum, and 1, -1 also local minimum or relative minimum, and also turning points, right? Turning points. That's it. Very good. So A, right? Great. Next question is computational. Number 8, it talks about figuring out what is the output value of this f minus g. It's a difference function, right? Evaluated at 2. So we're explaining the lecture that this is just this, right? F evaluated at 2 minus g evaluated at 2. And when you do that for this guy, if you substitute 2 here, I'm going to show you how to do it in case the numbers are not friendly on your final exam. Just do this, right? Replace 2 within parentheses wherever you see x, right? This is square plus 3, and that's it. Negative 17. Negative 17 is this guy, okay? What about this other guy? G evaluated at 2. Well, G evaluated at 2 is 2 minus 5, easy, right? It's just negative 3. So negative 17 for this, negative 3 for this, right? So let's just put them there. So if you do negative 17 here minus negative 3, this is positive 3 plus negative 17 is just minus 14, right? Minus 14. So the answer here. See, guys? Great. This one is division, same idea, right? Division functions. This is just f of negative 5 over a g of negative 5. And when you do this computation, the evaluations in each, as I showed you before, you're going to get negative 17 here. You can check on your Desmos calculator or in your scientific calculator. And this simplify is 18 over 8, 17, sorry, over 18. That's it. Okay. Very good, guys. So next question deals with a sum of two functions, but this time they want the sum of two functions in general, not evaluated at any number, right? But that's not hard because we explained that this f plus g function is defined as f of x plus g of x, right? You add the two formulas, the one that defines f of x, which is this 6 minus 2x, plus the one that defines this guy g of x, which is this, right? And if you simplify this algebraically, you will see that this is minus 8x squared, this is minus 2x, and 6 plus 2, 8. That's it. And therefore, the answer for this question should be this guy, right? You follow, guys? Yeah, be careful when you choose your answer. Let's do a perfect match, right? Great. Continue. Composition. Very important, composition of functions, right? How you do that in general here. They're asking you to do this G compose with f of x. You may say, Professor, how do you know it's composition? This hollow circle, guys, hollow circle means composition. Do not confuse that with multiplication, right? It's not multiplication, it's composition. Okay. All right, and we explained that for composition of functions, what you do is this. You go from right to left, sort of counterintuitive, right? From right to left. The first one that appears, which is f, you deal with the first, f of x. Once you are done with this, you put that as the input for the next function that appears from right to left, g, right? So this is what you gotta do. G evaluate that f of x. But f of x is this guy, right? 4x to the second power plus 4x, let me right here, plus 4x plus 5, right? Meaning you have to take this as your input and evaluate it at the g function, which says multiply by 4 the input, whatever it is this, right? 4x squared plus 4x plus 5. And then subtract 6 from the result, right? So do this. So you do the work, 16x squared plus 16x plus 20 minus 6 is just 16x squared plus 16x plus 14, right? Plus 14. And that's it. So you gotta look for your answer now is this, right? Yeah, very good, guys. Composition of functions. Now, this deals with multiplication of functions. Probably for the sake of variety, we should do it quickly. F times G evaluated at -2. You may say, Professor, how do you know it's multiplication? We explained that when you do not see any operator between the functions, it means it's multiplication, right? So this is just this. F evaluated at -2 multiplied by G evaluated at -2. But what is this? This guy, when you substitute -2 here in the f function, -2 plus 1, -1, right? I did it in my mind. If you cannot do it in your mind, you can use the calculator if the numbers are not friendly. And what is -2 evaluated here? This one probably we can use the calculator to compute it, right? 2 times -2 is square, square, plus 20 times -2 again. Notice how I'm using parentheses to substitute the value. It's a negative number, right? So these parentheses, they matter. -39, -39 result, right? So you write here -39, -39 times -1 equal +39, and that's it. Yeah, any comments, any question, guys? Just feel free to write it on the chat. I will read them. Very good. Moving on, guys. Another composition of functions. But this time, this composition requires the evaluation at -2, right? It's not done in general, but the method that we follow is basically similar. We go from right to left, The first function that appears from right to left is G, the G function, right? So you gotta do this first, G evaluate at -2. Once you're done with that, this becomes the input of the second function that appears from right to left, right? F. So let's deal with this, G of -2. What is that, G of -2? Well, if you substitute this -2 into the G function, which is this, you're gonna get what? Let's do it together. -5. And I'm showing you this, guys, because in your actual exam, the numbers might not be so friendly. So use your calculator to play safe in case you cannot compute it in your mind, right? Doing mental mathematics. So use this -29, right? -29. So this -29 output of G becomes the input of F, right? And F now evaluated at -29, use the F function now, will be 8 times -29, right? Plus 3. And that is -229, right? -229, big number. -229, right? Big number, guys. So this guy. Excellent, excellent. Moving on. Another composition of functions, but this time with tables, but we explained that if you are not given formulas, but instead tables, it's not that difficult. Just follow the general strategy, go from right to left. The first function that appears from right to left is G, so do the evaluation at G first. Once you're done with this, do the evaluation at F, right? Yeah, and anyone could tell me in the chat, what is the evaluation at G looking at the table, at this table of G? Anybody? G of 4, right? Hint, look at the number 4 on the table for G. Aha, I see. Very good, Julie, very good. Excellent, right? Yeah, just look at input value 4 on the G table. They are saying, oh, output value 7. So that should be 7, right? No calculators or computations are needed, right? 7. And what is f of 7 looking at this table? Anybody could tell on the chat? F of 7 looking at this table. F of 7 looking at this table. Savannah, very good, Savannah. You made my day. Is this guy, right? Yeah, what else it could be, right? So, so when you see table, guys, don't freak out. It's actually easier, of course, as long as you know what to do, right? So this 14, and that's the answer, right? Excellent, 14. Great. Now there's some graphing involved. So let's check this out. How to graph this guy. Negative tells you that you have to reflect. +5 tells you that you have to move your parent graph to the left, right? Remember, it's counterintuitive, this horizontal displacement. And -3 means that you have to push your parent graph 3 units down, right? Down. So basically, you start with this parent function, which is this chair-like function g of x equal x cubed, right? And you apply all these transformations. If you do that, guys, I'm gonna kind of quickly do it here because I wanna go over different things. The reflection will do this, right? More or less. The reflection. All right, then you have to move this 5 units to the left. So 1, 2, 3, 4, 5. Now the new one is gonna be here, right? Somehow. And then 3 units down, these 3 units down. And that's it. That's all you gotta do, right? 3 units down. So 1, 2, 3 here. So it's gonna be there, the last chair, right? The last chair. Yeah, and then when you look at this is the graph of this guy, right? Looking at the choices, if you look carefully, you should determine that this is it, right? This is the last chair here. This one. Right. And you may say, Professor, there are other candidates. I explained to you, if there are 2 candidates, use the y-intercept or x-intercept, right? And then check which one shows the x-intercept, and you will be able to see which one is the one, right? Very good. All right. So next is this, deals with absolute value, similar, right? Start with your absolute value function, which is this, right? One that looks like a V as in victory. This is y equals absolute value of x. Then use the transformations minus 1/4 means that you are going to apply vertical compression, right? You shrink it vertically because of 1/4. Then -4 means you move to the right here, right? To the right 4 units, right? So there, something like this, right? And then finally, this guy, the one that says -6 means that you move this down here, right? Down here. Look for these guys among the choices. Yeah, it's the last one, right? We should use another final color here. Down. If you look through carefully, you will see this guy. Very good. Moving on. Then we talk about inverse functions, right? And we said that the only functions that you can invert, the only functions that are invertible are the one-to-one function, right? Then this question is saying, does the graph represent a function that has an inverse function? For that, it has to be one-to-one. But let's see if this is one-to-one applying the horizontal line test. Look, if you apply the horizontal line test, clearly it's not one-to-one, right? It's meeting at more than 1 point, the graph, so clearly no. Then they are gonna ask you to figure out the inverse of functions, right? For example, this is one of them. I gave you 4 steps to this, right? 4 steps. First step says instead of f, write y. Step 2, interchange or switch variables, right? Step 3, solve for y. To do that, you can cube both sides, right? Y -6 equal x cubed. And finally, adding 6 to both sides, y equal x cubed plus 6, right? Now, the last step, sorry, is just a presentational step, right? Because it just serves to present the final result, right? This is the inverse function. Change the y for f inverse. And this is it. This is your inverse function, right? That's it. Very good. Great. Well, there are other forms. For example, this, let's do the same. Let's follow the 4 steps. First step, change f of x for y. Second step, switch your variables, x equal 5, x minus 9. Third step, this should be y, right? So third step, solve for y. To solve for y this time, I am going to multiply both sides by y minus 9, right? To eliminate the denominator. Do that. So you're going to end up with xy minus 9x equal these two cancel, right? So 5. Now I'm going to bring this guy to the other side by adding 9x to both sides. Xy equal 0, 5 plus 9x. And finally, dividing by x both sides, I get to isolate my variable y, right? So this guy ends up being this y equal 5 plus 9x over x. Final step, presentational step, is just this. Change this y for f inverse of x. This minus 1, do not confuse it with exponent, guys, is f inverse, right? So this is it. This is the final answer. Look for this among the choices, and it's here, right? Very good, very good. 5 plus 9x, the same as 9x plus 5. Great. Okay, so now we saw these examples also related to linear equations. Probably we can do it quickly. This one, which says that they want you to find the equation of the line L in a slope-intercept form, right? The solid line L, this is L, right? We gotta find the equation of that line. For that, I have a point here. 1,4 is there, right? 1,4. And I know that this guy is perpendicular to this dotted line, right? The slope of the dotted line is 2. How do you know, Professor? Well, because of this. The slope always attached to the variable, right? So a slope of a given line is 2. Let's write it here, right? A slope 2. Then what should be the slope of the perpendicular line? Let's use this symbol. Well, you do two things to this too, right? You change the sign first. It's positive. This slope will be negative, and then you flip this. So minus 1/2 will be the slope of the perpendicular line, right? With that slope, with this slope, and the point, they give you this point, right? 1,4. Use any method you know to find the equation, right? So I'm gonna use this one, y minus y1 equal m of the perpendicular line, right? X minus x1, right? It's called point slope form. All right, so substituting everything, this is x1, this is y1, y minus 4 equal negative 1/2 times x minus 1, right? Doing the math there, notice you may need to use the calculator here, right? You end up with this. Now you want to add 4 in both sides, right? This will be 0, y equal minus 1/2 of x, minus 1/2 of x. And then you have 1/2 plus 4. What is 1/2 plus 4? 4.5, right? But you see that here they're showing the answers in fractional form. Not a problem, because I explained to you guys, if you use your Desmos scientific calculator, you can help yourself out doing this. 1/2 plus 4, what's that? Is 4.5, right? We said. But if you want this as a fraction, 9/2, right? 9 divided by 2. 2 into 9 is 4.5, right? It gives you that option, so 9/2. So here, 9/2. And this is it. This is the equation of this solid line in a slope intercept form, right? So therefore, we're talking about choice A, right? Very good. Moving on, guys. So then we talk about application of linear equations. This is one of them, question 21. They say you can rent time a computer at a local copy center for $7 setup charge and an additional $4 for every 5 minutes. How much time can you rent for $17? All right, first try to model this rent, what you have to pay for a computer, represent that with R as this fixed cost, $7 fixed cost plus the variable cost. The variable cost is given by this, look, $4 for every 5 minutes, right? So $4, 5 minutes. This is gonna tell me how much I'm paying per minute, right? Per minute. And then that must be multiplied by time, right? The number of minutes that you need times t. So this would be a great model, right, for this situation. So what is 5 into 4? It's 0.8, right? But in case you don't figure it out, use this. 0.8. This time I need the decimal representation. So let's use this, right? T. This will be good for the modeling, right? This models the situation. Now they say, how much time can you rent for $17? Well, let the rent be equal to $17 and solve for T. That will tell you how much you can, how many minutes, right, you can get for $17, right? Solving for T, right? And you did this type of problems on your special assignments. We did this in our worksheets, right? Try to recall all that, guys. It's time to put everything together. So then T equal 10 divided by 0.8. 10 divided by 0.8 is just 12.5 minutes, right? 12.5 minutes. Very good. 12.5. In the end, you may attach the units, right? Minutes. Excellent, excellent. So this guy, right? Now let me say something here. This is not the only way to figure this out, right? If you have another way to figure this out, go ahead, guys. This is the time when you have to put all together. Some students, what they do is they take $17, they separate the fixed cost, take away $17, $10 left, and then they figure out how many minutes they can rent with $10. Do that as long as you figure out the answer is okay. Great, number 22. Number 22 is dealing with a company, Northwest, which molds plastic handles, which cost $0.10 per handle to mold. That's the variable cost. And there is a fixed cost to run the molding machine of $8,644 per week. If the company sells the handles for $4.10 each, how many handles must be modeled and sold weekly to break even? As soon as you see this phrase, break even, we explain in class that that means that you have to make the cost equal to the revenue, right? Revenue. This is how you break even. Cost equal to revenue, right? Now, what is the cost? They're saying that the fixed cost is this guy, 8,644, and the variable cost is 0.10 per handle, right? Per handle. So let's represent with X the number of handles that will give us this break-even point, and the revenue will be what you get out selling the item. So this will be 4.10x, right? X, great. Solve this equation for X. This should give you the answer, right? I'm gonna subtract 0.10 in each side. As a consequence of that, I will get this equal 4x Divide by 4 both sides, I should get the answer, right? Take your scientific calculator or the Desmos scientific calculator available for you in our website, in Blackboard too. 2,161. 2,161 handles, right? Handles. In the end, you may attach the units. You don't need to carry them along the process. That's it. Oh, this guy, right? Yeah, very good, very good. We reached to this part where you have to deal with complex numbers. Okay, so what to do with this? Division of complex numbers. Remember, in class, during the lecture, I recommended this method, multiplying numerator and denominator by what is called the complex conjugate of the denominator, right? Which for this complex number will be this 5 minus 3i. The sign of the imaginary part is changed, right? Yes, multiply this top and bottom. All right, what are we gonna get now? Well, on the top, you're gonna get 6 times 5, 30. 6 times 3, negative 18i. Here you're gonna get minus 15i. Here you're gonna get plus 9i squared, right? I squared. On the denominator, should be simpler. 25 minus 15i. 3i times 5 plus 15i, and that's the reason why I'm saying this is simpler, because these two guys will cancel, right? Minus 9i squared. This cancels. I squared is just -1, right? -1 we explained, because I is the square root of -1. So this is -1. So if you substitute that, I combine these two like terms, you get 30 minus 33i. This is minus 9, right? 9 times -1. Great. Now, that's on the numerator. On the denominator, the second, the third will cancel. This will be 25. This is -9 times -1, positive 9. Right? So if you continue working here, you're going to get 30 minus 9, 21 minus 33i. Here on the denominator, the sum of these two is just 34, right? 34. Now, mathematicians like to separate clearly the real part, which is going to be this once you divide 34 into 21, minus 33 over 34i, imaginary part, right? So this is going to be our final answer then, right? Look through, guys. This guy. Excellent. Yeah, and any questions, any comments, just let me know. Okay, 24, yeah, I think we are good. You may have to solve quadratic equations using your knowledge of complex numbers. This is one example. Notice this is invisible 1. So A equal 1, B equal 4, C equal 8, right? Let's solve this equation using our knowledge of complex numbers together with this so-called quadratic formula, right? Quadratic formula. X will be equal to what? Minus B, but B is 4, so minus 4 plus minus B squared, 4 squared, minus 4 times A times C is 8, right? I'm not using parentheses because the number is positive. When the number is negative, use parentheses. 2 times A, 2 times 1, right? Work this out. What is this guy in here? Let's compute it, okay? Minus 4 plus minus square root of, this is just 2. 4 squared minus 4 times 1 times 8, right? Very good, very good. So what is this guy? Turns out this guy is negative. You will see. Negative 16, right? Negative 16. So we have to take the square root of negative 16, but we have our knowledge of complex numbers that tells us that this is using complex numbers for I, right? For I. So this becomes minus 4 plus minus 4i over 2. Dividing 2 into each of these, this is going to be negative 2, right? Plus minus 2i. So two answers, right? Negative 2 plus 2i is one answer. And the other answer, negative 2 minus 2i. This is the solution set, right? And that is given by this guy. In any order, these two together, right? Yeah, this is done. Great. Excellent, guy. This one, it deals with the vertex, vertex and axis of symmetry of a quadratic function. We explained that we said that the vertex is found by computing this guy, minus b over 2a, right? A here is just this invisible one. B is 4. C, we don't need it, right? So it's minus 4 over twice A. This is negative 2. Once you have this guy, this is the first coordinate. The next thing you do is you evaluate this guy into your quadratic function, which is this. Negative 2 squared plus 4 times negative 2 minus 5. This computation, this is going to be a 4. This is minus 8. 4 minus 8 minus 4, minus 4 minus 5 minus 9, right? So conclusion, vertex should be just this, negative 2 comma negative 9. And what they call axis of symmetry is just x equal this guy, right? The first coordinate of your vertex, x equal minus 2. So this is telling us that the answer should be this guy, right? Very good. Moving on. Now they want you to graph this, right? Graph. For that, you can find the vertex, right? Following the method that I just explained, the vertex. And then this one, right? Minus b over 2a first. Compute that. A is 1. B is negative 2, right? So minus 2 over twice 1. That is just 1, right? Substitute this one into your function to get the partner of 1, the output value for this input value, right? That's not hard to calculate, right? It's just this 1 minus 2 minus 1. So bottom line vertex is equal to 1 comma minus 1. Axis of symmetry equal or given by this equation, x equal this guy 1, right? 1. All right, with the axis of symmetry, which is x equal 1, and this graph it here, right? X equal 1, axis of symmetry. And knowing the position of the vertex, which is here, 1 comma negative 1, you can draw the parabola, right? But now you don't know, we know that the parabola is going to be opening upward, but we don't know how narrow, how wide. So for that, compute y-intercept. Compute y-intercept. Y-intercept is gotten by letting the other variable, in this case x, be 0 in the function, right? And solving for y. So 0 squared minus 2 times 0. 0 minus 0, 0. So y-intercept turns out is just this, 0, comma 0, right? So it's this y-intercept. Let's use a different color here. This is the y-intercept, right? Right there. By the vertical symmetry, there is an extra point here that we can get for free, and then connecting these three, you should get yeah, and be careful here with the position of this negative 1, 1, because look at the scale here. It's different than the scale on the x-axis, right? So be careful there. Really, the vertex should be 1 to the right, yes, but 1 down, probably very close to here, right? So something like this. Perhaps there. Yeah, but then you connect the 3 dots and you're gonna get something like this, right? Yeah, so I hope you guys will be okay with this. And when you look through the choices, you will see that the answer is going to be this guy. Vertex, x-intercepts, this and this, as we saw, right? You can make it the graph bigger and smaller. By the way, when you're taking the exam in Blackboard, guys, if your screen is too small, the numbers are too small, type Control plus, it will make it bigger, Control minus, smaller, right? Use those tools to see clearly the data. All right, great. 27 now. A rock is propelled upward from the top of a building, 80 feet tall, at the initial velocity of 136 feet per second. The function that describes the height of the rocket in terms of the time is this. They say determine the maximum height that the rock reaches, the maximum height. Remember, for the maximum height, this is the building that they're throwing the rock, right? This is a parabola, right? That's opening downward. So you are looking for this point that can be found by computing first negative b over 2a. Again, this is where the maximum is reached. In this case, it's going to be 136b over twice a minus 16. We're going to compute this guy. Use your calculator. Okay, so 136 over 2 times. Notice how I'm using parentheses now because I'm dealing with a negative number there. This guy is negative 4.25, right? Negative 4.25. And that, yeah, this is minus, so positive 4.25, right? Yeah, minus here, minus or minus plus. So 4.25 is where the maximum will occur. So in order to find the actual maximum value, plug this into here. You have the function, right? It's S displacement function. So use that, and this shouldn't be a problem to compute. So let's use this function. So minus 16 times 4.25 square come out plus 136 times 4.25. And notice, guys, you have to use the calculator for this, right? It will be very difficult to do this mentally. Plus 80. So use your calculator. 364.75, right? 364. Yeah. Yeah, let's check what's happening. Yeah. 4.25 square. This is a 6. Yeah. Guys, whenever you get into this situation, you might get it right when you take the exam. Do not panic. Just check. Look, instead of a 6, I put a 5 there, but now it's good. 369, right? Excellent. Very good. Yeah. Yeah, just back up, check your work, and everything will be fine. Excellent. I saw. Yeah, guy, excellent, Ying. Good catch, right? Yeah. Very good. Continue. Let's continue. Yeah, this was 369. In the end, you may attach the units, right? Feet. Moving on. We're here at 28. The owner of a video store. This is similar, so we're gonna start skipping so we can finish, right? Similar. So do the minimization now, following the same method. This one deals with determining if the graph shows the graph of a polynomial function. For polynomial function, remember you require the graph to be all in one piece. This is not. This is in 2 pieces, so this is clearly not, right? For the trends, remember there are 4 scenarios. Those scenarios are here in. I put them together, in a sheet. If you go to our website, they are there under useful sheets. These are the 4 scenarios. You have to look at the degree and the sign of this guy, right? For degree odd could be a chair, increasing chair from left to right or decreasing chair from left to right. Depends on the sign of the leading coefficient, which is -6 here, right? If the leading coefficient is negative, is this, right? AN less than 0. So we're talking about a chair that is decreasing from left to right, right? From left to right. Yeah. Share decreasing from left to right, which is this, right? Very good, very good. Yeah. And all that because you just look at this guy, right? This guy odd and this guy negative. Very good. Yeah, moving on, guys, moving on. Let's see more example here. Division of polynomials, right? Division of polynomials. This guy, they're asking you to do the division. Let's do it quickly. Remember division symbol, minus 21x squared plus 64x minus 35 here. That must be divided by negative 7x plus 5. You always start by dividing the first term here by the first term here. This is 21 negative divided by negative 7, 3, x squared divided by x, so 3x goes here, right? 3x. You write it on top of this guy, 3x. Then you multiply this times this whole thing. 3x times negative 7 is negative 21x squared. 3x times 5 plus 15x, right? Next, you are supposed to subtract, right? You're supposed to subtract. When you subtract, guys, what I do is I distribute the sign. This makes it a positive 21x squared, negative and positive negative 5x. This cancels, right? This difference is just 59, right? 59x. Yeah, very good, very good. 49x, I think, right? 49. This is when you multiply, this is 15. Yeah, 49. Yeah, great. So now to continue, bring down the next term, right? The next term, which is negative 35. I'll repeat this again, right? This guy divided by the first term here, minus 7 is minus 7 now, right? On top of the constant term, multiply this times this, minus 7 times minus 7x, 49x, minus 7 times negative 5, minus 35. They happen to be exactly the same. So when you subtract, clearly you're gonna get 0 here, right? So answer is just this, the quotient, 3x minus 7. This, right? Very good, very good. This is called long division, right? But now there is this other method which is simpler. It's called synthetic division, right? Synthetic division and can be applied when the divisor is of this form, x plus something, x minus something, right? Let's do that. So here 1, 15, you just work with the coefficients, right? 49. And in this corner, you write the opposite of this, right? Opposite of this, which is negative 6. 1 comes down as it is, minus 6 here. The sum of these two, 9, positive. 9 times 6, minus 54, right? And when you do minus 54 plus 49, that is minus 5, right? Separate this from the rest. This is your remainder, right? So remainder minus 5, quotient 9, constant term, this is 1x, right? This is the answer. But also you can write this in this form. Quotient 1x, I don't have to write 1, plus proper fraction negative 5, the remainder on the top, on the bottom, the divisor, x plus 6, right? Now, minus and plus is just minus, right? So minus. So this is what you should look for among the choices. And if you do that, this is going to be, or this is going to show that this is the answer, right? Got it, guys? Another synthetic division, but this will be a similar, I will leave for you to do. Similar. It says, use the rational zero test to list all possible rational zeros of this given function. Remember, for that, you pay attention to the last number, the constant term, and the first one, right? The first, this guy, these two will determine that. So what you do is you take the factors of positive 8 on the top and factors of negative 2 on the bottom, right? And you divide them. Factors of positive 8 are plus minus 1, plus minus 2, plus minus 4. 3 is not a factor, not a divisor of 8, right? Itself, plus minus 8. Divisors of -2 or factors of -2 are plus minus 1 and plus minus 2. That's it, right? Now you divide this guy 1 into each of these. 1 into each of these, and you should get this. 1 into 1, 1, plus minus 1. 1 into 2, 2, plus minus 2. 1 into 4, plus minus 4. 1 into 8, plus minus 8, right? Now, time to do the same with 2. 2 into 1, plus minus 1/2. 2 into 2, plus minus 1, but that is already here, so you don't have to write it again. 2 into 4, plus minus 2 is already here, you don't have to write it again. And 2 into 8, plus minus 4 is already there, right? So this is the full list. Look for the answer showing all these numbers in any order. Mathematicians will write it in order according to the absolute values, but you just have to make sure that you are picking the one showing all these numbers. Okay, so if you do that, you will see that the first one, I think it's the one, right? Yeah, very good. 34. Yeah, excellent, excellent. We're good. Next question. This is find the vertical asymptotes of this guy. For the vertical asymptote, remember, first you simplify your fraction. In order to simplify, it is a good idea to factor the denominator, right? This is going to be x minus 5 times x plus 5 here, right? Notice, very important, right? These two guys are the same. So you can simplify them, right? Simplify them. And you end up with this. Turns out this guy is just this, 1 over x minus 5, right? In these guys, in simplified form. It is here where you do this. Now set denominator equal to 0, right? Yeah, very important to simplify because otherwise you're not gonna get it right, right? So it turns out solving this, the only vertical asymptote is just x equal 5, right? X equal 5. So only one vertical asymptote, x equal 5. That's it. This guy, right? Not both, right? This because this got simplified. Very good, guys. That was 35. Yeah, moving on. Now they may ask you to compute the horizontal asymptote as well. There are 3 scenarios, right? This is just one of them. This rational function is equally heavy. Why you say that, Professor? Well, because degree 2, equally heavy. And for equally heavy rational functions, we have this rule, right? The horizontal asymptote is determined by y equal the quotient of these two guys, right? This guy over this guy, 7 over 3, right? So y equals 7 over 3 should be the horizontal asymptote, the equation of the horizontal asymptote, right? Very good. 7 over 3. Excellent. Next question deals with graphing these rational functions. I gave you the 6 steps to graph these rational functions, right? But we're gonna summarize here by just focusing on the asymptotes, okay? And then you will see that this will determine the graph. If you look at the vertical asymptote here, notice that this function, when written in factor form, is this, right? You don't get to simplify anything, right? It's just this. So the vertical asymptotes, remember, are given by setting the denominator equal to 0. So from there, you can see that x equal 5 is one of the vertical asymptotes, and the other is x equal -5, right? And that comes from setting this equal to 0. Great. Now, these are the two vertical asymptotes. Let's put them there. So 5 here and -5 here. These are the two vertical asymptotes, right? Now, on top of that, horizontal asymptote. Notice this is equally heavy, right? 2 here, 2 here. Equally heavy. So this means that the horizontal asymptote will be given by y equal the quotient of these two guys, right? As we just saw, this and this. There's nothing here, Professor. That's an invisible one, right? Invisible one. So 4/1. Y equal 4 will be the horizontal asymptote, right? Horizontal asymptote, y equal 4. 1, 2, 3, 4 here. So vertical asymptote, horizontal asymptotes, right? Now, then you have to check in each of these regions using test points, right? Using test points. If you have to take this curve, right? Asymptotic here, or maybe this curve, right? When you use the test points, you will see that the curve that you have to take is this one on the top. Using test points. Again, guys, I'm summarizing this, the details you have them, right? Let's say you use the 0.6, evaluate, the output value will be over this 4. That will tell you that this is it. Similarly here, if you use -6, notice the evaluation will be the same because you're dealing with x squared. This is going to be the part of the curve. And if you use test points at the center, together with the fact that the x-intercept and the y-intercept is this guy, you will get this. Okay? But notice that the asymptotes are very important because they basically determine the graph, right? Look, the only graph that is showing those asymptotes that we found, the horizontal asymptote and the two vertical asymptotes, is this, right? And also good match with the shape of the graph. So this is it. Yeah, there is another version of this. I'm gonna do this for you. I wanna leave this for you to do similar. Let's move on, right? Let's talk about, well, but this one is kind of, this is the one with the, probably we should do this because this is the one with the slant asymptote, right? Slant asymptote, they want you to graph this. There is a slant asymptote because this one is top heavy, right? Yeah, let's do this quickly. Top heavy slant asymptote. And that slant asymptote can be found via division, right? You divide these two guys, x minus 4/x. This part we neglect. This goes to 0 for big values of x. So a slant asymptote is y equal x, right? You keep this part. That is here, right? Y equal x. Now, you gotta check using test point if this is this curve or maybe this curve, right? If you, let's say, use test point x equal 1. If you put 1 here, 1 minus 4 minus 3, or 1 minus 3 on the bottom, right? On the bottom, so somewhere here. So which tells us that the graph has to go this way, right? You follow it? And maybe I should put the test point 1 here, right? F of 1 using as a test point is -3. And similarly, using -1 here as a test point for this part, -1 square is 1, -3 on the top, but this -3 divided by -3 is just 3. So -1 goes with 3 up here, right? Up here, somewhere there. So this is telling me that this piece should be just this other piece right here. Like this, right? Asymptotic here, asymptotic here. So when you look for the choices, you have to choose this one now. Yeah, be careful there, guys. Great. Moving on. Now we talk about logarithmic functions, exponential functions. This is one example for an exponential function. How to solve this? I gave you this nice method. Whenever you can express these two numbers as powers of the same base, 3 squared, and for this one, 3 cubed, right? You should do it so. That way, you can solve this exponential equation by just saying, okay, this is 3 raised to what? 2 times this, right? 2x plus 10 here. And here 3 raised to what? 3 times x, 3 times 3, 27. To equal bases, it corresponds equal exponents, right? And that is why, or because exponential functions are 1 to 1. So solving this, you should get your answer, right? 10 here minus 27, adding 27 to both sides. Yeah, let's check this. 27 here. Yeah, so yeah, let's do it carefully. 3 squared, 2x to 10, then this is 3 minus 27. Setting them equal, subtracting 2x from both sides. I get x here, and adding here. Let's just double check here, guys. For a second. 3 cubed. Yeah, 2x plus 10 here equal 3x minus 9. This is a 9, yeah. Anytime, guys, this happen, just back up and see what is not working, and you will find it. So this is it. And now it's good. Yeah, and recall that these exponential equations, for you don't need to check them because they are okay, right? The domain is all real numbers, so it's good. 19. Next question: what to do in case you cannot express these two guys using common basis? Well, in that case, yeah, good, Julie, great, excellent. Take logs, right? We explained take logs. I'm gonna take natural log in both sides. Natural log. You can take common log, is the same. You take natural log, 4x minus 1 comes out. There is a property for natural log that says that. Natural log of 19 here. I gave you this advice, right? Divide both sides by natural log of 3 here to do this sort of efficiently. 4x minus 1 equal natural log of 19 over natural log of 3. Add 1 to both sides. 4x equal natural log of 19 over natural log of 3 plus 1. This is just a real number. So divide both sides by 4, and this should be it. This will be x equal what? Take your calculator. Natural log of 19 divided by natural log of 3 plus 1. All this, highlight all this, divided by 4. 0.92, right? 0.92. 0.92. And that number should be our answer is here, right? Very good, excellent. Okay, great. Then we talk about these applications to investments, right? Two formulas. This is for continuous compounding, right? This is for compounding done over a certain number of times over a year, right? So we know that. Let's do one of each. Let's say, let's pick this for the first representative. What will be the accumulated value here? Present value is 1500 times 1 plus R. R must be written as a decimal, 0.12 divided by N. N, since this is a quarterly, N is 4, right? And that raised to 4 times T number of years, right? All this. When you do this, guys, in your calculator, I'll show you now, you should get the following. 1 plus 0.12 over 4 raised to parentheses 4 times 2. And that is 1900.15, right? 1900.15 rounded 1900.16. This guy, right? Very good. So 1900.16 is the accumulated value. Great. Now, compounded monthly n equal 12, right? You know what to do. So it's similar. This is different. Compounded continuously. This word continuously tells you that you have to use this formula, right? This formula. Okay, so let's do that. So A equal present value E raised to RT. So present value here is 5,000. You're gonna multiply that by E, Euler number, R, the interest rate is 0.08 as a decimal times number of years 6, right? You gotta do this in your calculator. So you take your scientific calculator and you do this computation. 5,000 times E, where is E, Professor? Function E to the X, right? E to the X. Then you write within parentheses 0.08 times, where is times, Professor? Main menu here, times 666, close parentheses, and that's it, 8,080.37. 8,080.37, which is here, right? 1,080.37 dollars is the accumulated value after compounded continuously. Okay, yeah. So these are the two scenarios basically, right? Two formulas. Again, as long as you see continuously is this formula, right? Very good. This now shows more logarithmic equations. Let's see. Here, I explained this technique is nailed, right? 6 raised to 1 equal x squared minus x. Solve for x here. And once you solve for x, you are supposed to check, right? Check, because we are dealing with a logarithmic equation. When you solve for x, factor in this guy, you're gonna get that this x minus 3x plus 2 equal to 0. So x equal 3, x equal minus 2 are the candidates, right? But you gotta check them both. If you check 3, we explained that you have to put 3 in there and verify that this is true, right? This is 9. 9 minus 3, 6. Log base 6 of itself, 6 is 1. This checks, right? And when you check this guy, x equal minus 2, believe it or not, guys, this is also going to check. So just because a number is negative, it doesn't mean that we have to turn it away automatically, right? Check. This is true. Yeah, this is 4. 4 plus 2, 6. So it checks also, right? So both check in this case. So this good, this good. It means that the answer is 3 and negative 2. 3 and negative 2 here, right? Follow, guys, 44. Great. Continue. This one deals with condensing, right? Condensing. When you have a equation of this form, we explained that you have to condense using the properties of logs this way, right? And then you snail it, right? Then you snail it. So 4 squared will be equal to x plus 2 times x minus 4. 4 squared is 16 equal, foiling this out, x squared minus 4x plus 2x minus 8, right? So 16 equal x squared minus 2x minus 8, adding 8 to both sides, 24 equal x squared minus 2x. Moving this over, 0 equal x squared minus 2x minus 24, right? All right, great. So then factoring, you get that 0 equal to x minus 8 Actually, 6 and 4, I think, are the ones, right? 6 and 4 here. Factoring, you're going to get the x minus 6 times x plus 4 is equal to 0. Setting each factor equal to 0, you get as your candidate x equals 6, x equals minus 4. You're going to check these guys. If you put 6 in here, 6 plus 2, 8, good, positive. 6 minus 4, 2, positive. So this one is going to check, right? Negative 4 is going to give you trouble. Look, negative 4 plus 2, negative. There is no way to take the log of negative number, right? So this one, no good. So only this, x equals 6, which is here. Very good, guys. This is the way you condense using product rule in reverse. There will be another situation where you have to condense using quotient rule in reverse, this, right? When you see minus, you use quotient rule in reverse. You see plus, you use product rule in reverse. After you do that, you snail it, you're gonna get that 5 squared equal x plus 2 over x. 5 squared is 25. Multiplying both sides of this equation by x, you're gonna get here 25x equal, canceling these two, x plus 2, subtracting x in both sides, 24x equal 2. Dividing both sides by 24, you get this. Simplifying, you get x equal 1 over 12, right? 1 over 12. Now, when you check this 1 over 12, if you put it here, 1 over 12 plus 2 positive, so good, right? 1 over 12 here positive, also good. So this will check. So this will be good. We talk about that, right? Good solution. Great. That was for number 46. Moving on. We reached the trigonometric part. First question, find a positive and a negative coterminal angle of 43 degrees. I give you this nice technique to get positive coterminal angles at 360, a full round, right? Which means basically not changing the angle trigonometrically speaking, right? So adding these guys, you can use your calculator there. You're gonna get 403 for this and negative 317 for this, okay? Telling us that this is the answer, right? Very good, guys. The next says conversions here. I think convert the angle from degree measure to radian measure. They are giving us 450 degrees, not a problem. We multiply by this factor 180 degrees by radians, right? Let me write this right. I'm placing 180 degrees on the bottom because I want to get rid of degrees and output radians, right? So this will be it, 450 pi over 180, right? What is left is to simplify. Dividing by 10 both, this is what we get. Dividing by 9, numerator and denominator, you get 5 pi over 2. 5 pi over 2, there we go, right? Yeah, this one, convert these to degrees. You multiply by the factor now, pi radians on the bottom, 180 degrees on the top, right? I want to output degrees, I want to eliminate radians. So pi cancel with pi. There is a radians in understood that is written there. Mathematicians just write it. Let's put this right. This cancel with this. And this is the answer, right? This you can get in your calculator, 7 times 180 divided by 4. 7 times 180 divided by 4. 315. 315. That's it, right? Applications. This application deals with finding S formula. S equal R theta, where theta is in radians, right? So R is 5. Theta is 30 degrees. It's not in radians, not a problem. We can turn it into radians by doing this, right? Pi radians on the top, 180 is on the bottom. Radians, you don't have to write it. So you gotta compute this whole thing. If you put this in your calculator, guys, you're gonna get 2.62 inches. In the end, you may attach the units, okay? 2.62 inches, which is this. Very good. The other application is this, deals with area of a sector. The formula is this: area of a sector is equal to 1/2 r squared times theta, right? Very good. Now, we have 1/2 r is 16. Theta must be in radians. It's in degrees, not a problem. We can convert it to radians by multiplying by this factor, 180 degrees on the bottom, pi radians on the top, right? If you do this in the calculator, don't forget that the 16 is squared. You're gonna get the following: 44.7 square feet. In the end, feel free to attach the units, right? So it's this guy. Moving on, we talk about trigonometric functions. They are saying cotangent of theta equal square root of 3/3. They are asking you for sine. They are saying that the angle is an acute angle. Acute here, acute. So it means that you can place this angle inside a right triangle, right? Theta. It's acute angle. All right, but this cotangent from SOHCAHTOA tells you that this is tangent is opposite over adjacent. This is cotangent, so it will be adjacent over opposite, right? So make up a triangle where the adjacent is square root of 3 and the opposite is 3. Find your hypotenuse using the theorem of Pythagoras. And from there, you can find sine, right? Good. C squared is 3 squared 9. These two take care of the radical part, leaving us with plus 3. C squared equal 12. Taking square roots in both sides leads to C equal square root of 12. But that is square root of 4 times 3. Simplify. This is square root of 3 multiplied by 2, right? Yeah, very good. This is this guy, 2 square root of 3. Very good. Now, sine of theta will be then, sine of theta is opposite over hypotenuse, right? So we have that. Opposite is 3. Hypotenuse is 2 square root of 3. You want this in exact form, right? Notice. So multiply by square root of 3, both top and the bottom. So this will be 3 square root of 3 over 2 square root of 3 times square root of 3 square root of 9, which is 3. 3 cancels with 3, and this should be the final answer. Square root of 3 over 2, right? Very good, guys. Exact form, right? This one deals with simplifying. I think everybody should be okay with this now at this point. Tangent of theta multiplied by cotangent of theta, which is this, and then tangent of theta multiplied by cosine, right? Tangent of theta multiplied by cosine of theta. This is 1 because they are reciprocals of each other, right? 1 minus tangent of theta, sine of theta over cosine of theta multiplied by cosine of theta. This from the quotient identity, right? Finally, 1 minus sine of theta, this, right? Very good. That's it. And that's it. Use the calculator. This I will leave it for you guys. You can do it, right? Use the calculator. Just make sure that you're working in radians, right? For 54, and you're supposed to get this as your answer. Just make sure you're working in radians. Here's some applications. Yeah, so let's look at this as a representative, right? It's similar. They want you to figure out the width of this river. Let's represent this with X. This is the base, right? And this is 50 degrees. So a function that you can take to do this, right? A trigonometric function, a good one is tangent, because it combines this guy with this guy, right? So you go ahead and say, okay, tangent of 50 degrees equal opposite X over hypotenuse, not adjacent 110, right? and then multiplying both sides of this equation by 110, then you will get the value of your x, right? 110 times tangent of 50 degrees will be equal to x after you cancel this, right? Now you put this in the calculator, right? 110 multiplied by tangent of 50 degrees is just this guy in degrees, right? When you want the computation in radians, you have to click here, radians, right? But this one is in degrees. 131 approximately, right? 131, and that's here. Feet. In the end, you may attach your units. This is similar, okay? You can do it at home. Let's look for more forms. This one, for example, is find secant of theta using the definitions for trigonometric function of any angle. Remember, secant is 1 over cosine. Cosine is x over r. This will be r over x, right? R over x. But r is the square root of x squared plus y squared. So square root of -2 squared plus -3 squared. -2 squared is 4. 4 plus 3 squared, -3 squared is 9. 9 plus 4, 13. This is the square root of 13, right? So that is your r, is square root of 13. And your x, as you can see here, is just -2. So this is it. This should be your answer for secant. The square root of 13 over 2 negative, right? Negative. That's for this guy. Very good, very good. Yeah, and this comes from the definitions, right? This guy, negative here was somewhere in the third quadrant, right? That's why we did this. All right, great. Now, this is to determine where the trigonometric function is using all students take calculus, right? Where is cotangent negative and cosine positive? Cotangent negative and cosine positive here, right? So Q4. That's 58. Excellent. Find the reference angle. Yeah, I said if the angle is bigger than 1 revolution, a good thing to do is to subtract 360 degrees, right? But when you do that, you get this angle, 46 degrees, which is an angle on the first quadrant. Reference angles of angles on the first quadrant is just itself, right? So that's that. Now we reach to this part. Secant of this angle is 9 over 8. This is hypotenuse. This is adjacent, right? Find tangent. And the angle is on the 4th quadrant. So 4th quadrant, work with the reference angle. Remember this angle, reference angle with theta prime. Make up a triangle here where this is true. Hypotenuse 9, adjacent 8, right? Find this guy using the theorem of Pythagoras. B squared plus 64 equal 81. B squared equals subtracting 64 in both sides. This is 17, right? B equal square root of 17 is this guy. So they want tangent. Tangent is opposite over adjacent. Opposite we just found out is the square root of 17 over adjacent. I think it's 8, right? Prime. Alice prime. Yeah, Ali, what I mean is that this angle, the big angle is theta, right? This is the actual angle. It's on the 4th quadrant. But we work with this reference angle, with an acute angle associated to this big angle, right? Because the thing is, when you compute here tangent of theta prime, this is going to be this guy, right? A square root of 17 over 8, right? Yeah. But this facilitates the computation of the actual angle, the tangent of the actual angle. Tangent of theta will be equal in absolute value and the sign is given by all students take calculus. On the 4 quadrant, according to all students take calculus, this tangent is negative, right? Only cosine and secant are positive, this is negative. You follow now, Ali? Yeah, excellent, excellent. Yeah, very good, thumbs up. Yeah, that's it, right? Yeah, very good, excellent. This guy. Great. So moving on, the unit circle, very easy. If they give you something to find in the unit circle, is easy because we explained that the first coordinate always cosine, the second coordinate always sine. They are asking for both. So from here, this is cosine, this is sine, directly, right? No computations needed. So therefore, the answer is this, right? You follow, guys? Cosine inverse. For cosine inverse, you have to think of in reverse, right? What is the angle whose cosine is the square root of 3/2? Look at the unit circle, right? And for cosine, remember, you are allowed to look from 0 to pi for the inverse, right? So look from 0 to pi. What is the angle having the first coordinate is square root of 3/2? I found one here, right? Pi/6, right? Pi/6, 30 degrees, right? Pi/6, so that's it, right? Pi/6 here. Using the unit circle, so right? Next, this one tangent using the calculator. I leave this for you guys. Just use the calculator tangent inverse function. Make sure you don't confuse this with exponent, or it's tangent inverse. This one deals with the sign of the sum formula, right? It's easy. Probably we have to go over, yeah, this one easy too. Use these formulas, right? The ones that I gave you yesterday, I think. Yeah, this one, right? Yeah, sign of the sum. These are in our website under useful sheet. Sorry, they're not this ones. They're in the unit circle. Here. Sign of the difference is here. Here, sign of the difference is this, right? Maybe I can quickly do this. Sorry to see. What is sine of the difference of two angles? According to that sheet that I just showed you, is the sine of the first multiplied by cosine of the second minus sine of the cosine of the first. Cosine of the first for pi multiplied by sine of the second, right? This is the formula. Formula sheet. Sure. Yeah, okay. Is the one from the unit circle, this formula sheet. Yeah, but if you want this here, right? The link, this. Yeah, it's all, they're all in useful sheets in our website, but it's here. The one I'm using right now is this one, right? With minus. All right, but if you do that, notice this is 0, sine of 4 pi 0. So eliminate this whole piece. Minus cosine of this is just a cosine of 4 pi 1 sine of x. This all equal to minus sine of x, right? 64. Great. Yeah, this is similar. This one probably we should do. This one deals with the cosine of the sum, right? The sum. Yeah. The second sheet also, the second sheet of formula. Yeah, maybe this one. No, this one. No. There. Okay, the second sheet of formulas. No, this one, no. Yeah, the second sheet of formulas, I think is, let me check, let me find it here. This one, right? Yeah, you're talking about this one?
Yes.
Yeah, great. Yeah, this one. Yeah, they're all, if you go to a website in under useful sheets, but in case you cannot find it, this one, I'm giving you the direct link if you want to find, print them out. So
thank you, Professor.
Yeah, great. You're welcome. Thanks. Yeah. All right. So yeah, we are running out of time. So maybe I should show this one, right? it says cosine is this, sine is this, and the angles are the first quadrant, third quadrant. Find sine of A minus B. Sine of A minus B. Remember, by formula, this is sine of A, cosine of B, minus cosine of A, sine of B. Okay? Identify what you have. Cosine of A we have. Sine of B we have, right? Given. We have to find these two. Start with sine of A. Sine of A. For sine of A, you use the fact that this angle for sine of A, right? For A, angle A, is on the first quadrant. So it's here, right? Cosine is 1/3, so this adjacent is 1, hypotenuse 3. You have to find this guy, right? So 3 squared equal B squared plus 1 squared. 1 here, 9 here, 8. When you subtract B squared, taking square roots, square root of 8 in simplified form to a square root of 2. This is this guy. So therefore, this is telling you that sine of A should be opposite B, which is 2 square root of 2 over hypotenuse 3, right? 3. That's it. The sine of A. We found this guy. For B, they say that B is on the fourth quadrant, right? So it's here somewhere. I noticed that I'm not using polystyretic with sine of A. The first quadrant is positive, but here probably we'll use it. For B, it's on the fourth quadrant, B, right? So here, so use the reference angle, which is this B prime, right? There, you have to consider this. This is opposite over hypotenuse for sine, right? So hypotenuse is 2, opposite is 1. You gotta find this base now. A squared plus 1 squared equal 2 squared. 2 squared is 4, this is 1. A squared equal 3. A equal square root of 3, right? So therefore, cosine of beta prime first is what? The square root of 3 adjacent over hypotenuse 2. But cosine of B, since you are on the fourth quadrant, you have to follow all students take calculus, right? Cosine is positive, so same as this guy then, right? Yeah, there you go. This is cosine. But now, put everything in, right? Sine, I have now cosine of beta. So putting everything in, you will get this, right? Sine of A, so is this guy. Cosine of B is this guy, square root of 3 over 2, minus cosine of A. Cosine of A is this guy. It's given, right? Cosine of A, look, 1/3. And sine of B is given minus 1/2. When you do this computation, guys, simplifying, you're gonna get this 2 square root of 6 plus 1, plus 1 over common denominator 6. Okay, and this is this guy, right? Yeah, great, excellent. Yeah, this is now related to the double angle formula, sine of 2 theta. Sine of 2 theta also is on the unit circle sheet, is here. Double angle formula, unit circle here. Sine of 2x, 2 times sine x cosine x, right? That's the formula we're gonna use. This is twice sine of theta cosine of theta, right? I have sine of theta. I have to look for cosine of theta. In order to do that, they say that theta is on the fourth quadrant. I work with, this is theta, right? I work with theta prime, the reference angle, right? They say sine is 4 over 5. So opposite 4, hypotenuse 5. You find this guy, the base, a squared plus 4 squared equal 5 squared. A squared, this is 16, this is 25. 16 taken away from 25 is 9. A equal 3 once you take the square roots. So this is 3. So this is telling us that cosine of theta prime first is 3 over 5. but cosine of the actual angle, according to all students, take calculus, cosine is positive here, so it's the same, right? 3/5. So now putting everything in, 2 times sine of theta is minus 4/5, multiplied by cosine of theta that we just found is this. 2 times 4 is 8, 8 times 3, 24, minus here, 5 times 5, 25, right? Or you can use the calculator for this too. So this guy, 467. Yeah, this is for the half angle formula. Remember, we explained this too. Yeah, and for this, you can use this formula. It's on the unit circle sheet also, right? That you already have. Use this formula, right? For a half angle formula is straightforward. I think we should finish up with something related to the very, very last part. Converting these guys, I think it was product to sum. So yeah, the graph in this also, you gotta follow sine of x, the wave shape, and for cosine, the curve V, right? But I wanted to perhaps, yeah, this, I think you should be okay. But this guy, the one that we did at the very end, right? Cosine of 2 theta multiplied by cosine of 6 theta. What is this as a sum? As a sum. For that, you have to use these formulas. Sorry. Yeah, and in case you don't have this last sheet of formulas, I think I already gave it to you, but just in case, like this. It's the last sheet of formulas that we use. Yeah, this is it, or it's in our website. Just go there under useful sheets. Yeah, notice that this gives you formulas to transform products of cosines into a sum. This, right? It says 1/2 cosine of the difference of the angles plus cosine of the sum of the angles. We're gonna use that, okay? So for the first one, we say, this is 1/2 bracket cosine of the difference of the angle, so 2 theta minus 6 theta, plus cosine of the sum of the angles, 2 theta plus 6 theta. And this is all in the last lecture, guys. I did a lot of examples of this in the lecture that I gave yesterday, the day before yesterday, I think. So you can check that out there. Cosine of minus 4 theta here, simplifying. Cosine of 8 theta here, simplifying. Now, this guy is the same as cosine 4 theta, right? Because we have this property for cosine. Cosine doesn't care about the sign of the angle. Cosine of minus x equal cosine of x property. Right? You don't have to take out the sign. They are the same. So this is the final answer after you distribute 1/2 as a factor multiplying here, right? So this is it. I gave this one and I do not simplify this two. You cannot write this cosine there. So just look for the answer there for 83 then. So cosine of 4x, 4 theta, sorry. This is not a 0, it's theta, it's a Greek letter, right? Letter from the Greek alphabet. This should be it, right? 483, I think.